RAHN, your partner for excellence. Updated Pressure-Sensitive Adhesives Lab Report. Today's PSA market presents us with very challenging demands. We must provide a well-balanced adhesive with good peel, tack, and shear properties. There is a high demand for high temperature and humidity resistance, as well as an adhesive that is fast curing. Today's PSA applications are dynamic and versatile, with a trend towards high-end applications. We find the need in the medical industry. For example, they are used in disposable needle housings and medical tapes, in electronics for LED displays and locas, which are liquid optically clear adhesives. We see them in appliance tapes, glass and jewelry applications, and in mounting tapes for automotive and construction. Due to the challenging demands and trend towards high-end applications, we at RAHN have updated our PSA lab report to address those challenges. The lab report provides comprehensive starting point formulations, which address today's adhesive market needs. Our goal was to develop 4 specific UV Curable PSAs with strengths in each respective testing property. The first formula is for a high Tack PSA. Second, a high shear, high SAFT PSA. Thirdly, a low peel or peelable PSA. And the fourth, a well-balanced PSA. Before we get into discussing the formulations, let's touch on the 4 essential components that comprise a UV Curable PSA. First is the elastomer component, which gives us the real performance properties of the PSA. It enables the adhesive to be extended or compressed upon pressure, helping to wet out a substrate. Upon removal, its elasticity allows it to extend greatly before separating, giving good peel and adhesion properties. The second is the tackifier component or inert resin. It has a lower molecular weight than the elastomer. This difference allows the elastomer greater mobility in the system. It maximizes both the deformability under light pressure and its elastic behavior upon adhesive removal. Third is the diluent component. It is a reactive monomer that acts as a diluent and plays a similar role to the tackifying resin. It aids in viscosity reduction, and its low molecular weight allows greater deformability of the elastomer. The final essential component is the photoinitiator. Its job is to dictate the manner of adhesive cure. We must keep a balance of properties through formulating with a combination of through cure as well as surface cure. Our first target formulation is for a high Tack UV Curable PSA starting point formulation number 309. Remember, the Tack is the efficiency of a PSA to conform to a given substrate under minimal external force. This formulation is great for high Tack performance when cohesion and heat resistance is not needed. We will see that the low TG and low cross-linking will offer very high Tack performance. Here we see the formula for the high Tack PSA. Our first component is the Genimer 4188 at 18%. It acts as the elastomer component in the formulation. Genimer 6043 is the tackifying component at 55%. The diluent of choice is EO-EOEA monomer at 23%. And the final component is the photoinitiator, Genicure LTM at 4%. The low functionality, low TG products, 4188, 6043, and the diluent all work together, giving us a PSA that has high Tack, low shear, and very low heat resistance. Overall, a great formulation that gives us a high loop Tack of 3.5 pounds per inch squared. However, due to the low functionality products, cross-linking is limited, which results in low cohesion. The lab report also includes suggestions on how to modify your Tack properties. It is possible to adjust your Tack by changing your functionality and TG. Our second target formulation is for the high shear, high SAFT PSA, starting point formula number 255. Remember, shear and SAFT performance is an illustration of the cohesion of your PSA. The formula offers excellent shear and temperature resistance, also maintaining its peel strength and loop tack after 14 days of humidity testing at 50 C and 50% humidity. The cross-link density will contribute to its high shear. Here we see the high shear, high SAFT PSA formulation. We maximize our cross-link density by incorporating a difunctional elastomer, Genomer 4269, a trifunctional polyester acrylate 03-849, and a difunctional Genomer 5275. Since we are looking for increased temperature resistance, our diluent of choice is isodecyl acrylate. This combination of higher cross-link density and the incorporation of isodecyl acrylate will result in excellent shear, indefinite shears, and increased self-failure properties. Modifications to the high shear, high SAFT PSA are also provided. In order to work towards the increasing demands for high temperature and high humidity resistance, we at RAHN are continually developing products to support these demands. I'd like to take this opportunity to introduce our experimental product, RCX-12-952. RCX-12-952 is a difunctional urethane oligomer cut in Genomer 1122. It is also being studied in an AHA cut version. It offers low Tg, high molecular weight, and a good working viscosity of 60,000 millipascals at 25 C. Our initial test results indicate maintenance of high peel after 5 days at 85 C and 85% humidity. We have a good balance of peel, tack, and shear properties, as well as an increase in SAFT. However, please keep in mind that it requires use in an optimized, well-balanced PSA formulation. Here we have the optimized PSA formulation using the experimental product in starting point formulation number 317. By adding RCX-12-952, we build in cross-linking, therefore increasing shear and SAFT properties. In combination with our other elastomer component 4188, the tackifier 6043, and diluent isodecyl acrylate. The result is a good balance of peel, tack, and indefinite shear properties, as well as a notable increase in SAFT value. We move up to a failure of 140 degrees C. Let's take a look at our standard high shear, high SAFT PSA formula versus the optimized high heat, high humidity PSA. By incorporating the experimental product RCX-12-952 at 40%, and a combination of Genomer 4188, we build in added heat resistance with our tackifying resin 6043 and diluent isodecyl acrylate. This optimized formulation allows us to maintain comparable loop tack, peel strength, and shear properties while giving an increase in our SAFT. Our third target formulation is for a low peel or peelable UV Curable PSA, starting point formulation number 307. It will offer low tack and low peel for release liners that can be repositioned or discarded. It also shows an absence of residuals and ghosting after 14 days of heat aging. And here is the low peel formulation. We increase the functionality by adding a trifunctional elastomer Genomer 4316, which provides for low peel and tack properties. In combination with Genomer 4269 and diluent isodecyl acrylate, we provide for low TGs, adhesion, and the flexibility we need for the PSA upon removal. We have just enough loop tack, 0.1 pounds per inch squared, peel strength, 0.4 pounds per inch to have a low peelable PSA. We also want to ensure that shear properties remain strong due to a large use of low peel PSAs that are used in the automotive and construction industries for temporary protection of materials. The peel properties can also be modified by increasing or decreasing the functionality and TG as well. Our final target PSA is a well-balanced adhesive, starting point formulation number 137. It is a nicely balanced PSA with exceptional adhesion and shear properties, plus added heat and humidity resistance. The formula maintains peel strength and loop tack after 14 days of humidity testing at 50°C, 50% humidity. As we look at our final well-balanced formulation, we see everything previously discussed all come together. Our elastomer components are now balanced with the addition of Tackifier Co-Resin 02-819. It helps to maximize elasticity, increase peel and tack properties while maintaining strong cohesion. As a result, we get a balance of good peel strength, 6.4 pounds per inch, loop tack, 1.7 pounds per inch squared, and definite shear at room temperature, decent shear at 80°C, and a SAFT failure at 96°C. Overall, a good starting point formulation for a well-balanced PSA. Now that we've discussed PSA market trends, PSA components, and formulations, we've come to the product discussion page. This is a very useful page because it summarizes the products, gives descriptions and properties, and provides very useful comments to help you in the formulation process. Our last page is for other recommendations. There are a lot of things to keep in mind while formulating an adhesive, such as viscosity, compatibility, and cure speed. Here we have included suggestions on how you can maximize your adhesive properties by keeping in mind other factors that will affect your bottom line.